will start to talk a little bit about, I always feel kind of apprehensive when I'm talking about education because I would wager that I'm probably one of the least educated people in the room. I didn't go to college, and I didn't go to college because I didn't really understand what it was for, and that was 35 years ago. I had come from a very varied educational history, ranging from special programs in elementary school where they pulled me out of school 2 days a week and they provided just a big open area with every tool of chemistry and physics and books and creativity, paints, and they just said, you can do anything you want for 2 days. The only condition is you have to, at the beginning of the 2 days, you have to say what you're going to do. And then the teachers just stood around on the wall and you called on them to answer your questions or to help you. And from there, I went to the only Montessori junior high school at the time in the country. And from there, I went to Sweden for 2 years and was part of a, contrary to popular belief, probably at the time, a pretty primitive math education that left me at a disadvantage when I returned to the States. One of the memories I have, quite appropriate to some of Conrad's comments, was being in the math class in Sweden and seeing locked in the cabinet a calculator. And this was probably 1973. And I asked the math teacher, could I use the calculator to calculate all of the, I don't remember what it was, like the days everybody had lived, and then use it to create the average? And the answer was just no. Go back to your, so there I was. I had a problem I wanted to solve. I wasn't allowed to use the tools. From there, so when I came back to the States, I was way behind in algebra and was forced to do a lot of the work on my own, and then had the good fortune to land at a prep school in Massachusetts, of all places, which was one of the first secondary schools that had a computer for educational or academic purposes, St. Mark's School in Massachusetts. And in the mid-'60s, they had the foresight to buy a digital PDP-8 and use it to teach, or use it to allow kids to learn rather than teach, actually. To this day, I've never taken a course in computer science, but I remember that there was a 9th grade course, and the first lesson was sit in front of the computer into the teletype, just start asking the computer questions. What was Babe Ruth's batting average? Well, with Siri now, we can ask those questions. Back in the day, you just got syntax errors, so you had to figure out, what this thing actually did. What was it computing? So after that, I was fortunate to build an Altair 8800 computer in my basement as a high school science project, and that was the computer that Bill Gates dropped out of Harvard with Paul Allen to write the basic language for, and so I always joke that that's what 2 years of, even 2 years of Harvard education will do in terms of your net worth as compared to mine. But we both so I came out of high school having that sort of leading edge experience with microprocessors, personal computers, and some of my classmates went and were doing, chose to go to college and, would call on me for help as they were writing matrix multiplication programs in Fortran. So it didn't make sense to me to go backwards in time and learn these ancient computing skills when the brave new world was opening up ahead of us. And I said, it's sort of in retrospect, I think it's for the first time the pace of innovation in the real world was vastly outstripping the pace of innovation in the educational system. And unfortunately, that still is the case. I have two twin boys, that's redundant, but I have twin boys, 16 years old. And a couple years ago, Bob Metcalf, a friend best known for inventing the Ethernet, a degree in applied math, was over at the house. And I don't know how it came up, but my kids sort of asked, well, what is calculus? And, I started to get into a cold sweat because, how do you answer that question in a way that's relevant? I think, when you have a curve and you want to measure the area underneath it, that doesn't happen very often. When you want to calculate the instantaneous rate of change of a function, that's not going to really sell the idea either. And Bob said, well, he says, if you have a gun and it shoots a bullet into the air, it'll go a certain distance. And calculus is a way of describing out of all the possibilities, the one that will make that bullet go the farthest. I'm glad I didn't, a little bit, maybe not a little bit violent example perhaps, but still, it's describing a parabola and it was a more rational explanation that I could give. But so now I'm involved in a number of things. Anyway, I've always been very pragmatic about what I choose to learn, as opposed to what I am educated in. I choose to learn the things that I need to learn in order to do what I want to do, or some things that just are interesting to me. The first business that I did, and I'll give you an example. Well, to back up, I think Conrad has said a lot of the things that I would say. I think we teach math backwards. We're teaching it from the bottom up rather than the top down. Reading, writing, and arithmetic, reading and writing are two sides of the same coin. They're about communication, and arithmetic, math, is also a language. And having moved to Sweden when I was 12, well, coming out of an educational system where I'd studied Spanish for 6 years and I could barely, say a word or order, a cheeseburger, within 6 months of being immersed in a Swedish classroom, not understanding a word of Swedish coming into it, within 6 months I was fluent. So we know that the way that we teach languages in school is not the way that we need to teach, or the most efficient way of learning a language. Yet we kind of haven't figured that out for math, that the way that we teach math is not the most efficient way to become fluent in the language. And math is a language. It's a way of describing the world just the same way as reading is understanding the world and writing is describing it. So I don't know, how much I should say about the experience in industry, but I'll give two very brief examples. When I was in my first company, it was an enterprise software business, and one of the issues is you you have a pipeline of products you're selling to customers, and the pipeline, says, well, you've got a $50,000 deal, and it's got a 50% of closing, and we've got a $10,000 deal, and it's got a 50% of closing. So I think probably what we're going to do this month, says the sales VP, is $35,000. Well, $35,000 is one of the numbers you can't possibly hit in any combination, right? So I kind of scratched my head, and on a plane flight home, I said, when you have that, for 100 deals, it's really what you're doing is flipping a coin, and then in every outcome, you're saying which deal's closed and which doesn't, and if you plotted those, you get kind of a bell curve distribution, and then for a 90% confidence that that's the area under the curve, that would give you sort of the number that you would, with confidence, reach, in the majority of cases where that coin flip is, when the probability in the real world. And little did I know is I had invented Monte Carlo analysis, which it took me a couple of years to even learn there was a name for it. But it was driven out of a need to better understand my business. So that's an example of, of a way math, even what we would say is relatively advanced math. That technique was originally developed at Los Alamos to model atomic decay and creating the nuclear bomb. So that's relatively advanced, but it's simple. And it was driven out of need. I don't need to know every underpinning of probability to reach the conclusion that the way that we're doing it was wrong. So that's the kind of, I think the math needs to be integrated as a language into all courses, just as computing does, but I won't cover the computing territory. I'm a huge believer that we won't, in 20 years, we're not going to be teaching computing. It's like penmanship, it's something you use everywhere. It's not a separate topic unto itself. So the other example is now I'm involved with NASA and the STEM initiative. We're spending billions of dollars, and then there's this kind of a vocal portion that says, no, it shouldn't be STEM, it should be STEAM, because arts needs to be in there too. And to me, I've argued vociferously against that, not because I don't believe in art as being important, but it implies that creativity is not a part of these other matters. And anybody who's looked at, the proof of Fermat's list, I haven't even looked at it, but if you don't think there's creativity in a mathematical proof, you don't understand what math really is at its core. It's something tremendously creative. And yet we do such an excellent job of beating that out of kids. We really are good at teaching them that this is not something they can be creative in. It's just extraordinary. So, last example, and then I'll sit down, is in music also, if you say, well, I'm a musician, I'm not a mathematician. Well, if you look at musical notes, you got whole notes, half notes, quarter notes, eighth notes. Well, that's 1, 2, 4, 8. Each note has a duration, which is a reciprocal of a power of 2. So really what musical notation is, it's shorthand. Each note is actually shorthand for a binary digit in a certain length of word. And then if you figure out how many can fit into a bar of music, you're really doing binary arithmetic. And in fact, in some ways, you're doing it more efficiently because you can, with one symbol, express a depth that would require multiple bits if you were doing it in a mathematical way. And of course, you have the other piece of information about the note, which is what note it is, what frequency it is, so that in fact what you're looking at is a symbol that, because of its graphical position and its design, is actually representing like a three-dimensional vector. But these are just different ways of describing the same underlying concept. But you go through music and you don't go, I hate music because it's too complicated and I don't like binary, no, you're just doing it. It's completely logical. And it's just another example of the way from the outside in, if you find something you're interested, if you dig deep enough underneath it all, you'll find math.